Hi all, welcome back to another SAGIS Training video series. My name is Surya Madathil and I work as a water quality modeler at Atkins Realis. You guys would have already gone through the basics of SAGIS-SIMCAT, setting up a model, creating that file and plotting results. But before modeling, it is always a good practice to check that all the features and reaches in the model are represented correctly. So in order to make sure that they are indeed at the correct location, we may need to move or edit the existing features. So in this fifth video of the series, I'll be taking you guys through the process of adding or editing and moving features, reaches, and also will give an introduction to editing of water bodies. Before going into the video, it is strongly recommended that a copy of the model is always made before edits are being carried out. So in this video, I'll be using Seglandia, which is a test model to show the different types of modifications generally done in SAGIS-SIMCAT models. So the different modifications are categorized as number one, addition of new features like addition of a discharge feature, that is a treatment work, or a flow gauge station or a monitoring station. Number two is moving of existing features to its correct location. Number three is addition or editing of reaches to make sure that they are represented correctly in the model. And finally, editing of water bodies. So to make this task user friendly and to ensure that it is carried out correctly, SAGIS provides a suite of editing tools. If you see here in the right hand side top of the toolbar. So the first modification that we are going to do today is addition of a new feature. So to add a new feature, we simply have to select the new feature tool located here. So I've selected that. But before adding a feature, we should be aware of the spatial location of the feature that we are going to add so that we can place them at the exact location. In this example, I am going to add a sewage work and let's say that it's located somewhere here. So I'm going to zoom into the location, right click. So once we do that, a menu pops up like this which says create point feature and select a feature type. And it lists the different types of features that we can add to the model. And today we are going to add a sewage work. So I'm going to select that and say create. So once the new feature has been added, it appears in the map. Since we added a sewage work, we can see a black triangle which represents a sewage treatment work. But to make sure that this addition has happened correctly, we'll select the feature and open the sim features table. So when we open the sim features attribute table, we can see that a new row has been added which says feature type discharge, feature description sewage works, feature code number 3. So all these 3 and the unique ref are automatically updated by the tool. So the user need to update the WQ data code, feature name and SIMCAT feature name. So a full description of each field can be found in the SAGIS user manual and I am not going to go into detail in this video. So that's it for the addition of a sewage work. So now we have added a sewage work into the model. So once a feature is added, its associated tables also need to be updated. So for sewage work, we need to update two tables. One is the SIM discharges table, which resides in the regional database, and the other one is the discharge quality table, which resides in the common tables database. Now let's see how do we update these associate tables for a sewage works. Okay. So the first table that we need to update is the SIM discharges table that is in the regional database. So you can add the database into our catalog by going into the database tab, see add database, and then navigate to the folder where the databases reside and select them and give OK. So I'll go to the regional database, go to the SIM discharges table and open. So once you open, you see there are these existing features with their flows. So the SIM discharges table defines the flow of the treatment works. Now let's go to the SIM features table and select the feature that we have just added, which is a sewage works. And make note of the unique ref which was automatically created by the tool. It is 81. And now we need to give it a name. So I'm going to name this as STW, let's say X. Same would be the SIMCAT feature name. And this WQ data code field is very important. This field and the unique ref field. These field will be used to link the data between the associated tables, that is the SIM discharges table, discharge and the discharge quality table with the SIM features when we do open and update. Okay, so let's update the WQ data code as well and make sure that it's a unique value. I'm gonna give a number 140 because I know if you look here, the last WQ data was around 137, so 140 is not a duplicate number. Okay, now let's go to SIM discharges table. Do the same. So the ID is same as the WQ data code, which we just updated as 140. If you know the concern number, you can update that. For example, if it is an existing asset, they will already have a permit number and you can use that. If not, you can leave it blank. It's not a mandatory field. Update the SIM name. In this case, it's STWX. And then if you know the easting and northing, you can also update those, which is not mandatory. But the next mandatory field is the unique ref. So if you remember, it was 81. So make sure that it's updated here. It should also be unique as the name suggests. And next is the flow. What is the discharge flow for this particular works? I'm just giving some dummy value. Let's say 1. SIM feature type is 3 since it's a discharge feature. I'm giving it like a standard deviation of 0.6. Shift value of 0.025. That's it. Okay, and make sure you save them. Yes. The next table, associated table that we need to update is the discharge quality. Okay, let's go to common tables database. Open the discharge quality table. So it says discharge quality. Open table. It will be a bigger version because this consists of data corresponding to different determinants. In our case, we are going to update for, let's say, BOD and ammonia. So make sure that the table is updated correctly with respect to the determinants code. This field is a text field, so that's quite important. Similar to updating the SIM discharges, we are going to add a new row. The SAMP user, this field is same as the WQ data code, which was, if I'm not wrong, 140. So update that. And the next is the determinant code. For phosphate, the det code is 0180. So what I'm going to do is I'm going to copy an existing det code. Okay. And then give some arbitrary values where you have measured discharge quality data, create a summary stats, and then update this table. In this case, since it's a dummy model, I'm going to use some dummy values as an example. Okay, I'm going to give some values here and count as 20. Okay, so in discharge quality table, the important field to update is the SMP's user reference, which should be same as the WQ data code in the SIM features, and then the dead code is in a text format. So I've updated for phosphate. Now I'm going to add another row, and I'm going to add data for ammonia. Okay, so ammonia, the dead code is 0111. I'm going to do the same, just to make sure that's correct. Copies, okay. I think that's fine. I've updated 0111, gave some arbitrary numbers. That is the mean, standard deviation, and count. Okay, and then save. Yes. If you check the SIM features table, you can see that at the moment there are all null values. So this field, flow mean, flow and pile, and flow shift, corresponds to the discharge flow that we have given in the SIM discharges table. And then corresponding to each determinant, the discharge quality will be updated in these columns. So the first determinant in this is ammonia 0111 dead code. And once we do open an update, we'll come back and check whether these are updated or not. So since we have added the data, the corresponding data in the associated tables, once we do open an update, it will link the SIM features table with the SIM discharges and discharge quality table. So the link is, as I said before, the WQ data code, which is the ID, and the unique ref field. So let's see whether it's doing the purpose. So what I'm going to do is I'm close these tables, and I'm going to say just SIMCAT, open an update, run. Okay, so the open an update is complete. Now let's go to the feature and open the SIM features table to check that the fields for the flow and the discharge qualities are updated. So I've selected the newly added feature, WQ data code 140, feature name STWX, scrolling to the right. You see here flow underscore distribution, flow underscore mean, flow underscore end pile, flow underscore shift. These were all previously null values. Now these are all updated with the values that we had given in the SIM discharges table. Scrolling again, let's check the discharge quality values for the determinant selected. So we had updated for ammonia and OP. So ammonia dead code 0111, mean, standard deviation, distribution, and number of samples all have been updated from the discharge quality table based on the dead code and the WQ data code. Same for orthophosphate. If you see, the values have been updated from the discharge quality table. So that's how you update the associated tables for discharge features. So if you're adding a monitoring station, you would need to update the sample point quality table, which resides in the common tables database. If you're adding a flow gauges station, you should update the SIM river flow gauges table in the regional database. And if you're adding an abstraction feature, you should update the SIM abstractions table present in the regional database. Now let's move on to the next modification, that is moving a feature. To edit the position of an existing feature, the user should go to the Edit toolbar menu and select the move tool. So once you select that, it asks to make a selection. So we should carefully select the feature that we need to move. So in this example, I am going to move the newly added sim features. So I've selected that. You see sim features, and I'm going to move it slightly to the right. Finish. So if you see previously it was here, now it has moved to this location. So the edits are not permanent until saved by the user. So we need to click save button here in the edit toolbar. Save edits and say yes. So that's it for moving of features. Now let's move on to a complicated one, that is addition of a reach. So to give a context, the existing river lines in SAGIS models are based on the GIS data provided by Environment Agency when the models were first built. Okay. Although the existing river polyline include most of the WFT reaches, it is a good practice to review the network in the area of interest for a study, particularly in relation to a discharge feature or an abstraction location. Because adding a missing reach may improve the routing of flows into the river, which might otherwise be applied at the wrong location. Editing reaches is very complex as it involves modifying pre-existing reaches and or manually editing them. So these modifications also have implications for the related tables. So for reaches, the associated tables are sim reaches and sim nodes tables. So basically there are 6 different types of reaches in a SAGIS model. So number 1 is a headwater reach. So it's a reach where a water course will start. There will be no upstream reaches, and it has got a start node type head and the node feature type as 10. So the two associated tables are sim reaches and sim nodes. Then comes confluence. So when two or more reaches join, they make a confluence reach. Then there is bifurcation reach, continuation reach, final limit reach, and virtual reach. So to add a new reach, we will use the add new reach tool in the editing tools. So I'm selecting that and I'm going to draw a polyline starting from top to here. So it's always recommended that when new reaches are added, they should be drawn on top of a cartographic layer that is loaded onto the map. Since Saglandia is a test model, we don't have that, and I'm drawing a reach at random. But when updating a SAGIS model, always add a map and then draw on top of it so that they are represented as accurately as possible. So I'm going to this location. This seems like a nice reach 50. That's nothing else. I'm going to draw a reach starting from here. And right click and say finish. So if you see here, a new reach has been added. And if you see previously this was one reach, it has been split into two, and the confluence node has been added here automatically, and the head node has been added here automatically, as this is a headwater reach. So we can go to sim reaches table, select the reach which we just added, and make sure that the data has been updated. So if you see here, automatically it has added all the information here. Start node type head, unique ref updated, water body number updated, sim length updated. We can manually update the reach name. Next, we can open the sim nodes table. Select the nodes here. So if you see here, a new reach that has also been added into the sim nodes table with the node type head. So that's it regarding adding a new reach. There are other reach tools present in the editing tools. If you see here, there is a split reach tool and a reverse reach direction tool as well. And it performs the functions as the name suggests. Since we have added a headwater reach, we also need to recalculate the up area field. So the up area field represents the upstream area of a water body that is associated to the headwater node. So what we can do is go to SAGIS and use the headwater area tool, and it will automatically calculate the headwater area. So if you open the sim reaches, you can see this upstream area which has been calculated. Now let's move on to the next modification, which is the editing of water body. So similar to reaches, editing of water bodies is also a complex process and requires modifying several related tables and can potentially compromise the model. So it's also advised that the edit process is only carried out by experienced modelers. Today I'm going to show you guys how to split a water body. To split a water body, we go to SAGIS editing tools, and if you see here, split water body tool. So I'm going to draw it here, and it should pass the boundary line and say finish. And it asks us, do you want to update the flow estimate? Yes. So based on the WB flow estimates table, it would update the flows in the water bodies. So if you see, previously this was one water body, now it has been split into two. We'll open the sim water bodies table, select the two water bodies. If you see here, previously it would have been named only GB water body 10. Now another one with a suffix _1 has been created. So 2. So one main thing to note here is reaches should always break at water body boundary location. If you see here, this is one continuous reach, and this will create a problem in SIMCAT. So what we need to do is go to SAGIS, use the split reach tool. So I'm going here just before the water body boundary. I am going to apply the split reach tool. So what it does is it breaks the reach at the water body boundary location. Previously it was one reach, now it has become two, and a continuous node has also been added here. So if I go to map, select this reach and go to the sim reaches table, it should have been automatically updated with start node type as continuous. Yes. So once we have created this extra water body, it is necessary to add a boundary plotting point at the end of the reach. Okay, so this boundary point will be used by SAGIS to process the SIMCAT outputs. So one of the important things to note is that when we create output tables, these boundary point plotting points are used to process the SIMCAT outputs, which is in turn used to plot the sector charts. Okay, so let's add a new boundary plotting point. So at the end of this reach, you can see this is where our reach ends. So I'm going to add a plotting point here. So it asks for us to select a feature type. I'm going to say plotting point, say create. So this will be similar to how we have added a new feature before, that's the sewage works. So a plotting point is added. Now we open the attribute table. I'm going to select this. You see a new feature type plotting point, feature description plotting point. Now we need to add a feature name. So the feature name should start with GB boundary, and it should also contains the water body ID. So I'm selecting the other water body boundary point, which was there previously for the whole catchment. So it is GB water body 10 boundary. I'm going to copy this, paste this here, and then if you remember, we had created a new one which was _1. So we need to save it with the same name, so that when we plot outputs, we know for which water body we get the outputs for. So that's it regarding editing of water bodies. So the last modification that we usually do is removing or excluding of features. So this usually happens when features have been taken out of service or they no longer exist. In this case, what we do is we select the feature, for example this, go to SAGIS, you see point settings, feature settings, and go to options and check the exclude button and say apply, close. So you see here, now it has become an excluded feature. So this provides a record that it was once there and may have some residual impact. So we have gone through the different modifications that are generally done in a SAGIS-SIMCAT model. Hope you guys understood. That's all for today. Thank you for watching and happy modeling.